Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
You don't see the curvature of the Earth. That stuff is flat.
GLOBEBUSTERS taking over. Bye bye, moon man and rover. NASA so mediocre. Sorry, but your ball is dead. But your ball is. GLOBEBUSTERs taking over. Gotta ride this roller coaster. But the truth is getting closer. Sorry, but your ball is dead. But your ball is. Get the shovel for the spice hubble. Piecing up the puzzle. Need to burst your bubble. Evil gonna crumble, yeah? Sit down, be humble. Got the ball, you better fumble. You'll get mad, cause at this fight involves your uncle.
And then they call me the liar. I mean, it's absolutely unbelievable the pathetic techniques that they have to use to prove their heliocentric model.
Bob to the president, Jaren got the evidence. Eros laying Jesuits and Zack is evident. That the earth electric and it's resonant. Your resident is heavens and I hope to settle in like some sediment. If we so wrong, why they lying to discredit it? That's not too intelligent. That's a guy, not an in court, but we ain't really in the settlement. It's time to awaken from the pseudoscience sedatives.
GLOBEBUSTERs taking over. Bye bye, moon man and rover. NASA so mediocre. Sorry, but your ball is dead. But your ball is. GLOBEBUSTERs taking over. Gotta ride this roller coaster. But the truth is getting closer. Sorry, but your ball is dead. But your ball is.
Inner World Productions.
In a world. All right, what's up, fam?
Hold on. They're going to say hi to me first. So
All right, we're gonna go to him first. So, GLOBEBUSTERS, season 13, episode 4, Sky Miles to Ground Miles. Distances on a planar Earth. We're gonna introduce the panel, and first up, we got my boy Zack from Good Times for All. What's going on, brother?
Hey, I hope everybody's having a great day. I'm just coming back from a flat Earth meetup at Bolton's. What was it?
Bolton's Curbside Eatery.
Curbside Eatery in
Mount Holly.
Mount Holly, North Carolina. Man, it was one of the best burgers I've had in decades, I would say. If you know anything about flat burgers, where they really smash them real flat, it's how they used to do it back home up near Chicago. And yeah, it was awesome. Got to see, what would you say, about 15 people there?
Oh, I'd say there was more than that.
Maybe
Like
20,
25.
25. Yeah, it was a nice little meetup. But yeah, heading back. Sorry I'm running a little bit late, but you know how it is when we all get together. It's hard to say goodbye.
No worries, brother. Thanks for jumping on, even in the car. Cool stuff. I was a little late too, so it is okay. We will forgive you. All right. We also have my boy Alan from Space Odyssey. What's going on, bro?
Hola, amigos. It's good to see you all here for our weekly gathering session.
Yeah, man.
It's going to be an awesome episode. Shaden's going to relay some pivotal information to understanding where we live and how we navigate where we live and the tools necessary to do it.
In a world. Shane, what's going on, brother?
What up, fellas? Good to be back. Been a while. I think 2 weeks. Good long time. Good to be back with the Sunday crew hanging out, man. Yeah, we're going to be addressing some things, hopefully, that if you go on TikTok, these will be the first things they try to get you with, right? So preparing the crowd.
Oh, not the TikTok, which I gotta go ahead and say a bunch of flyers on TikTok. You guys are retarded. You're saying retarded stuff. You gotta chill, man. You gotta chill with some of the retarded stuff you're saying on TikTok, bro. All right, look, know what you're talking about before you talk about it. All right, no one's gonna tell you. I'll tell you. All right. Now, some people cool content on TikTok. Some people, nah, man, the sun's not in the clouds. Chill out, bro. You know what I'm saying? All right. Little tough love. I love you guys. All right. Anyway. I'm kind of delirious, so we're gonna hand it over to Shane. I think right from the rip though, and let him get into the presentation. Pretty cool. This is a topic that seems to perplex the mind of lots of people, right? Because they don't really know how we come up with distances, how that correlates into the sky, how do we verify distances, how do we put it onto a map or projection? Exactly what is that? What's the longitude latitude system, et cetera, et cetera. And very pivotal pieces of information in terms of trying to figure out what's going on or kind of understanding the conversation. So looking forward to it. Haven't seen it, haven't heard it. and I think it should be good. So anything anyone wants to throw in before we hand it over to Shane?
No, we're good. Whenever you're ready to send it.
Cool.
All right. So are you going to actually share the screen on here, or are you going to use your...
Nope. Actually share the screen. Let's see. Presenter
If you want to support the
window.
stream, kofi.com/globebusters. We're also on X at the GLOBEBUSTERS. We should be streaming there as well. All right, cool. We're going to fall back and let Shane take it away.
There we go. Looks perfect. All right. So, I don't know if you see like questions in the chat that are relevant, definitely stop me to throw them in, right? As they occur to you and the boys, definitely throw them in. I'll stop, I think, at regular intervals to try and collect them, but it's going to be a good one, I think. So we're doing sky miles, which is, you know, basically a nautical mile. Where does the nautical mile come from? Units of measurement within ratios of each other, the metric system. How did it all come to be? How does it sort of fit together? Well, the starting point for most of it is coordinate systems based on angles to the stars, right? We always say this, but longitude and latitude is the literal equivalent of living on a flat plane, observing a hemisphere around you with which the stars appear to rise and set as they process around you. Different latitudes mean that this is at a different zenith and that the center of rotation moves correspondingly with your position on the Earth. We're going to explore that specific relationship a little bit, and we're going to see how it relates to nautical miles. But before we go super into it, just know that it's simpler than they're making it, right? They're doing a lot of... Oh.
Exactly. I mean,
Yeah.
like this can connect to cell tower and make
One
Zack.
sec.
exactly.
Yeah,
So what?
I'm figuring out how to mute him. There we go.
No worries.
I got it. We're good.
Car support. So it's simpler than they're making it, right? We don't need to use the two-sphere model, or as Ptolemy would put it, the terrestrial and the celestial sphere model, which is what his book was based on and all of cartography is based on. It's simpler than all of that, right? We could just be living on a flat horizon with a simple local alt as grid, and we could just be taking measurements of angles to the stars in our curved horizon as we see it, right? All of this theoretical math comes from mathematically calculating the bottom of this, which, you know, no one ever sees. It's from the assumption that when you don't see a celestial object, when it sets, you can use the circumference of this grid and you could predict when it will come back around just by using the same math you can up here, but having a negative value for this fundamental plane. So when things you don't see, you actually use the exact same math to keep track of them, but it has a negative value. So that's why the hemispherical view lends itself to a spherical coordinate system so nicely and neatly. So when we're going to get into what the nautical mile is, essentially, this is what it is. This is the definition that it's always had. 1 minute of arc, right? And we know 160 minutes of arc equals 1 degree. So this is the nautical mile's historic definition. Ties it to a unit of a circle. It is, at its heart, no more than a ratio. When you get to this part, 1 degree equals 60 nautical miles, that, although now part of the definition, is the part that we would put into question. The amount of terrestrial land traveled when the stars process 1 degree over you is, I think, under hot dispute. It's always been under dispute. It depends on your latitude. So to have this definition tied to it as it does today is problematic. But before we go into that, let's just break down what 1 minute of arc would be, really. So you have just an arc second. If you were to say draw that out and figure out what that is, it's just a unit of a circle. You can divide it to 360 degrees, meaning that 1 arc second would be 360, right? So 360 of those to complete a full circle. Carrying that math, you can further subdivide it into 60 sections, right? A minute of arc is 1/60th of a degree. And, whoops. Let's go over here. Right. Well, what that's describing is the amount that it would move on your celestial dome. Right. So this is how everyone observes the sky, whether you live on a globe or you live on a flat Earth. This is the observable reality, right? This is the canvas in which we make measurements. This is a local alt as grid. If you were to relay where you would see a star, right, you'd give it an elevation angle above the horizon and your azimuth, which would be from true north and 360 degrees around you. With those two coordinates, you can relay where you see stars and write it down. So for the next part here, we're going to concentrate on what the nautical mile is defining, right? And what it's defining is the amount of land that would pass under you, required for you to precess laterally for the stars to precess 1 degree. So if we move forward here, this is how we see the sky, no matter what model we believe in. And again, if we move forward laterally, 69 statute miles or 60 nautical miles, then the stars above us will precess 1 degree, right? So it would look like this. So the amount that we're arguing over, or that we're going to stipulate around, or what is tied to now the definition of a nautical mile, is this amount. This amount right here, when and where that applies, how it was calculated, what the range of it could be, how it was originally used, and how we're using it today. That's pretty much going to be the basis of this, 69 miles per degree. So if we go the other way, of course, it would look similar, right? If you go precess 69 miles laterally or 60 nautical miles, then the stars appear to precess 1 degree. So that 1 degree is a unit of measurement, and that unit of measurement is what we're going to be defining. So if we just quickly define the unit of measurement, it's just a way to standardize quantities and compare physical properties. Specifically, when you ask what units of measurement are, we have the metric system, which we're going to be going into very specifically. It's the most widely used system in the world, of course. And then we have the imperial system, also known as freedom units, good old American measurements. Now, comparatively, these are always just ratios of the same thing. When we get into it, they're actually just different measurements of the same thing. That's why feet is defined in meters and defined in inches and defined in everything. So if we look at just our comparison chart, right, these are the equivalences of all the units of measurement. So you start with, say, a centimeter, which is what, 2.54 inches, which is what, 12 feet, and there's 3 feet in a yard, and there's 5,280 feet in a mile. And you guys are getting it. The correlation over here is nautical mile. We're going to use this one a lot. This is the definition as they equate it to a 10 millionth of a terrestrial meridian, but we'll get into that with more detail. Here's how it relates to regular statute miles. 1 nautical mile, 1.15 statute miles. We're going to use that a lot as well. But you would notice that if you didn't know what any of these were individually, this chart would tell you very little information of how long any of these are. If you don't know what a meter, inch, or centimeter is, you have no understanding of how long these units of measurement are. They are all ratios of each other, which is indicative in a system of measurement. So when we look through the history here, we're going to reference this book. It's only from, I think, 1949, so less than 70-ish years old, but it's got some good info in it on the historicity of the nautical mile. It's called The Nautical Mile by Lieutenant Commander Alton Moody, and we're going to use a couple pages here. So he starts off by saying the length of the mile is controversial, right? It has always been controversial, and the nautical mile, as distinct from the land mile, he says, might be said to date from this time. Previously, there had been no distinction between the two. So he's saying that before this date, which again, 1637 is what he's quoting, there was no distinction between nautical and land miles, meaning you would use the same for either. That seems more simple to me, especially when most of the world is covered by water anyway. It would make sense to use the same unit of measurement, which of course would have to be inherently tied to the stars, the only thing you can use to differentiate where you are on the earth when at sea, right? So it says that there was less incentive to associate the mile with the size of the earth, and the old Roman mile of 5,000 feet persisted. So that was actually, a Roman mile was, I think, in a metric of 1,000 paces, ends up being, I think, 0.8 nautical miles comparatively. But what this is saying is that there was an incentive to associate the mile with the size of the earth. This is a precursor to what we get in the 1700s with the meter convention and what they're going to do with the ratio of a terrestrial meridian and light speed and a Palladian bar and all that stuff. He also references now, this is a metric time. He says, the mile later became 5,283 feet. Well, he says 80, but it's 83. And that's, by no means universal. So he's just stipulating that's the modern equivalent. Says, as for the nautical mile, after his measurement of an arc of the meridian, proposed that the length be set at 6120. So here, very in the early days, we have the desire to set the distance of a nautical mile, meaning a unit of measurement, to some metric of the earth. And in this case, an arc of a meridian is a terrestrial meridian. It's the distance on a sphere from North Pole to the equator. It is a curved geodesic. So if the earth is flat, right, guys, then this doesn't exist. And we're trying to equate a unit of measurement to an arc length of something that isn't real. So the only possible way that would work is if we're ratioing against the coordinate system itself, because the coordinate system certainly has a spherical shape and a distance from North Pole to the equator that can be calculated at 69 or whatever X nautical miles per degree or whatever. So that we can ratio it against, but an actual Earth measurement can't be done because that's not real, right? So when we move it on here, it says that it was gradually accepted by seamen, but it was not known by the distinctive name nautical mile until 1730. So he's saying that they had previous to this land and sea miles together, and there was no distinction. And then after this, they were trying to make a distinction, the latter of which they were trying to decree in relation to a terrestrial meridian. Again, a piece of an inherent sphere that if the Earth isn't spherical, doesn't really exist. So that's problematic. I would think that would be problematic for most flat earthers. Little tidbit though is before we move forward, when the Romans were doing surveying, they always used the Roman mile on the shore, and because they thought the Earth was flat, all the charts considered the Earth a plane, didn't allow for the convergence of meridians. So of course they had to fix that. 1700s came along, but we'll get into that a little bit later. Moving on to the next.
Before we move on, you're telling me that they didn't care at all about distances on the ground. It was all in relation to the positions of stars, essentially, to figure out where you want to go.
Yes.
Measurement derived from a circle.
Yep.
To relate that.
Yep. It's a ratio, right? So the only thing that differs is how big is your circle? Well, how big is your circle? Well, so it depends on the latitude, right? Because even on a concentric flat Earth, you'd have different latitude circles of different size, and theoretically, they'd be 69 miles bigger each time. So depending where you are is how you would measure how big of an Earth circle that celestial arc would take, right?
Yeah, so at the end there, they started to move towards standardizing the coordinate system and units of measurement to be associated with it, so that they could associate the positions of the bodies in the sky to the ground, essentially, because the dimensions have to be identical for there to be a translation.
Yeah, so, from other history, this is right about the time that the Royal Society took a hand in academia, started doing learning against learning, pushing the heliocentric model, pushing back the church on all their various historical, blasphemies concerning the cosmography. So right in here, if you know your history, there is let's say, a concise and motivated, wealthy approach to try and push the world towards one spherical coordinate system. So you could also argue that the drive to make it related to a terrestrial meridian came from this group as well, right about the time where they claimed power and started pushing for other things that they needed for the same coordinate system. So
yeah, I was looking at the year there, 1730, and then it wasn't much long after that, 1777 or 1776, really, when they made the royal decree that everyone was now on the Lati and Longi system. And all units of measurement were going to be ratios of that as well.
Yep, that's a keen eye, Alan, noticing timeline consistencies here. We have our good friends to keep track of who have the best of intentions concerning academia and education, of course, right? And to steer us towards nothing less than scientism, essentially. And so it was their hand here that would push this coordinate system, and I can't prove it, right? But I would argue that it's their hand that pushed this nautical mile differentiation, and then of course the ratio towards the coordinate system and the Graticule itself.
Yeah, I mean, they are all about consolidating things into one controllable, mechanism. So it makes sense that there was a push to do this. And then think about how accurate you could make it, and then you would have the power to tell everyone. Basically, you could give them their cosmological belief system based off of positions of the stars. It's quite a thing to unify and merge.
Yep, and they did so with the help of these ellipsoidal, geoidal, spheroidal models, which were also coming up about the same time, right about 1900s, 1800s. They had their first one. I think late 1700s was their first spheroidal model. And then they were like, oh, you know what we should do, guys, now that we have these great spheroidal models, is we should make one standard nautical mile to be established and based upon a minute of a great circle on this giant spheroid, right? So when I said before, depends on how big your circle is. That's, well, yeah, that's exactly what they did. Sure, it's a ratio of a minute of a circle, but depends where you are and how big that circle is to get the required ratio. So the standardization that follows this kind of solidified the globe metrics and measurements, which we'll get into, but so far have never been actually measured on the Earth, but have been inferred and calculated from angles to the stars and assuming parallel sun rays and angles to the sun. That's where this metric comes from. That's what the spheroid model is built on. That's what they're, quote, measuring, right, on the Earth. Nothing to do with the Earth. If you notice, this references another survey. They love their geodetic surveys in 1880. We'll get into that with specificity later, but just know this is the point where they decide, oh, you know what we should make it of? Instead of a ratio of what we know is a spherical Earth, we'll just tie it to this spheroid model, in which case we have a known dimensions previously, and we know exactly how big it is, right? And we'll get into how they confirmed all that as well. So again, if we back to our book.
Can you go back for a second?
Yep.
So that table of different names, like the Bezel, the Airy, the James Clark, the Clark, the Hayford, multiple Hayfords actually. These are all ellipsoid models, right? And these are the dimensions for them, right?
Yep. And the difference in the mean radii, and then the ellipsoidal models, the mean foci differences. Yep.
Yeah. So I remember this from a book called The Explanatory Supplement to the Astronomical Ephemeris and American Ephemeris and Nautical Almanac. And basically what they were doing is it was like a book on the history of how they surveyed out the ellipsoid models, because we've all heard that the Earth is an ellipsoid, you know, but like, what does that even mean, right? Well, the correction angles that are provided in the Nautical Almanac every year, this was a story about how they came up with those angles, right? So they went and took zenith measurements to stars, like you were saying, following elevation angles and the difference between true north or whatever. They would come up with, or, you know, when they would triangulate the star, take a cosine to it, and then use a unit of measurement derived as a fraction of the coordinate system itself, so that they could complete the triangle to do this. They go and take a zenith measurement of the star, and it's never quite where they expected it to be. And they have this idealized snapshot, like you were saying, with parallel light rays coming in, because the whole model is like built on the assumption that it's like the backbone of their cosmology too, that the stars are physical and that they're sending in these parallel light rays. They have this idealized position, and the deviations from that are what they're using to create the ellipsoid model. So when you look at these ratios, they're the difference from a perfect sphere.
Yep. Which had to make them create more and more models. Notice there's no shortage of models, right? And apparently a model is a name, and you can just name your own model. So
if you had a name and you could do cosines, you got yourself an ellipsoid model, my dude.
I think they apply the same rules to map projections nowadays. Anyone with a name can have their own map projection.
So yeah, if you ever see anything that says ellipsoid or geoid in it, you're automatically referencing the stars inherently. That's because that's what it's built upon. That's what the history of the almanac. That's what that entire book is about.
Yep. It's good to have people know what this is in reference to, right? Like, oh, you just got a good old ellipsoid model to tell you where your flat plane deviates from that curve that's not there, right? That's what that is. That's why it's there. It's what it's the catch-all for. That's what the deflection of the vertical is meant for. When you go to that triangle that you're calculating and you can't actually get the star in the zenith, that's okay. That's just the whole basis of a ground position, how a zenith works, right? Like, we'll just patch it together and keep going.
Well, you know what's really interesting about that too is like from that royal decree that they made, where they were unifying the system and making it mandatory, they were also they were still having trouble unifying the system for two observers to use the same stars or whatever. Like it was to come up with corrections so that they could both circumnavigate Britain using the same stars. And what that relates to is really that, like the idea that there's an exact position of a star is false. That it's all apparent to us locally, and the coordinate system that we're using is built on, like, you could call it like a two-party reference system, where it would be the idealized position for two observers to see the same thing if you could triangulate it, if it were a real object at a certain altitude, right? Because that's what's required for it to be so accurate, even though that position doesn't exist and it's the difference between two apparent objects. That's what they've made the whole thing off of the backbone of it, right?
Yep, that's how they stitch together the celestial sphere, right from the beginning, the backbone of all of this, by separate alt as individual grids, right? People make stellar observations at different latitudes all over the world. Using the latitude dependency and some sort of metric, you can stitch those separate observations together to form what is the celestial sphere, right? To get those negative values below everyone. And then you have this theoretical model, which you can employ anywhere on Earth using infinite tangents to a sphere of infinite radius.
Yeah. Okay, cool. I just wanted to cover these ellipsoid and spheroid models, because that is the backbone. Like these deviations from the stars based off of apparent positions is the backbone of the globe model. This is how they came up with it.
Yep. So back through our history for the nautical mile from our book again, he says that in ancient times they used the cubit, the foot, the pace, the stadium, and the league. Now, and again, these old school units have no relation to any terrestrial meridian or coordinate system. This is literally, I think it starts with the length of a foot, which gets 3 feet in the pace or something, and then that many paces in a stadium, how many stadiums in a league. They just keep adding metrics of units. Sure, they're ratios of each other, but this has a basis in reality with a starting metric, and that's why they had to get rid of it so that they could use a metric based on a coordinate system. This is just more sort of equations. This is where I got from before. The Roman mile would be 4,800 feet ish, which is 0.8 nautical miles. So we remember the Roman mile was 1,000 paces from before, which again now we know equals 4,800 feet. And if we go further into the book here, this is actually from a different book quickly called the Hydrographic Review, and this is just saying that it's calling out that the Roman method of shoreline navigation, or to map out and chart all the shorelines, which even today are notoriously hard to do, says that they used the Italian charts and with a survey of order of magnitude of the Roman mile, or a mile of 1,000 paces. So they surveyed the whole world using a Roman mile. It's interesting to say. Thought that was interesting. If we look into the basic breakdown of how Roman equivalent units would work, they go from a finger, inch, palm, greater palm, foot, cubit, then the step, pace, and they went over before the perch. So I mean, they had a good system. I think this is all in millimeters, but you could equate it to inches if you want to. But this is just so we can see how they built up from one to another. And again, 1,000 paces would be a Roman mile, which is a mile past us over here. So it says that even though all early miles were defined in terms of other units, they were in no way connected to the size of the Earth, which is what we were just pointing out. So even though they're ratios of each other, no one's ratioing a terrestrial meridian, a thing that doesn't exist, a curved geodesic arc of any sort, a metric of a coordinate system that's just theoretical. None of that has taken place with any of this. So, enter our boys, the Royal Society, or according to them, not until the period of great discoveries, when charts and greater distances become important to the mariner, and the association of the units of length and degrees become a serious consideration. So again, this is like light subtext from our boys with an agenda. Well, you know what we should do, guys, lads, gentlemen, is that we should start using our charts and distances, and we should become important, and we should equate these units to degrees of latitude. So now we're invoking our spherical coordinate system, our wonderful backbone of how we get sphericity and how we get geodesics and tie units of measurement to it going forward. But this is just put over as like a light interest. Oh, you know what we should do? We should start to do that. And then it says a links ascribe to these miles, thus depended upon the size of the Earth accepted by the individual. So back to the former statement, Al, when he was like, how big is it? Well, how big is your circle? How big is your circle? Well, my circle is bigger than your circle, and my mile is going to be longer. That's the latitude dependency joke, I guess. And they said that the estimates varied considerably. Here's the range here, ranging from 44 to 87 modern nautical miles per degree. So that's almost a good range. If we have it set at 60 nautical miles today, you can tell that there has been a various degrees of discrepancy going from 40 to 80 to try and figure out what that might be. Factor in today what we know and how concentric circles would get bigger, and then we would know that range would apply via latitude. That would make sense to us today. So moving on, this is another reference to our favorite book here. It says the shift to a minute mile, which is now universally accepted, did not come about at once. Originally, it was 60 Roman miles, which is 4,800 feet, which were considered equal to 1 degree. So instead of 60 nautical miles, we had 60 Roman miles. We're just going to swap that out for a metric of our spherical coordinate system because reasons. And so as later measurements of the Earth began to reveal the error of these accepted values, where 1 nautical mile was seen to be an error, 1 second. There we go. So by the 16th century, they were considering 70 Roman miles to equal 1 degree. And by the 18th, it was 75, resulting in a degree of 59.9 miles. So the whole point of this little blurb here is that it was under constant updating. And it wasn't static. People had different sizes for what they thought it was. And even using the same ratioed metric of an arc minute, right, 1 degree, they still had different corresponding miles on the Earth depending. And they couldn't quite figure it out yet. So problem, reaction, solution. No, there's a problem with the standard meter size. Let me break into the Paris Academy run by our friends, the Royal Society, and our friends who had just established the Board of Longitude 20 years before this. So in 1735, they sent an expedition from the Paris Academy sent to Peru, which is near the Ecuador, which is on the equator, where they would, quote, measure an arc of the meridian. Yay! To provide more accurate determination of the size of the Earth. Now,
how'd they make that measurement?
Geodetic surveying. So they went to go measure it by already knowing it. But we'll go into that in a little bit. I found that particularly funny. So yeah, you used a method of measurement where previous dimensions have to be known to first determine the dimensions of Earth. Got it. Solid logic. Anyway, let's see. So now we go into the modern definition, right, of how they're going to standardize it is that they're equating it to this, right? They have the spherical coordinate system, also known as the Graticule. They're saying a nautical mile is this, right? At the equator, it's this distance right here. Boop, goes this far, north to south. That's what they're saying. That's what they're tying the definition to, so that when you look it up on Wikipedia, it would say, you know, a nautical mile is 7,912 statute miles or whatever. No, sorry, 69 statute miles, and it's ratioed against, you know, an arc of the meridian, and they give you an actual measurement in kilometers of that. But is that the actual definition as we just went through the history, or was it always based on an arc minute, and that they have only recently standardized what that arc minute is a great circle of? To put it, yep.
So they just recontextualized it and just tell the story as if this is like a unique thing that they, you know, standardized.
Yeah, so if you look it up now, it'll preface its definition with historically. So that's how you know it's super duper true. They say historically it has always equaled this amount of on a geodesic curved Earth. That's what they say the nautical mile is if you look it up on Wikipedia. So instead of going through the history of how it was 1 arc minute, 1 ratio of a circle, how that gets construed and how that can have different corresponding land values, which is the proper history, they'll tell you straight up, it's always been this way. It's always been this amount. It's never been anything else.
Oh, that's so weird because we just read how it was different things, undefined, changed for everyone. There was no unified system, but somehow everyone still got where they were going.
Yeah, and that's a whole nother can of worms and how they imposed the spherical coordinate system onto the world by the ways of sailing, saying, oh, sailors are getting lost. We must have a standardized measurement. But really, that wasn't, I mean, like they were staging accidents and stuff, but people could, you know, straight line navigate. They could do dead reckoning. They could figure out directions cardinally. They could look at the moon. They could do lunar transit to get a form of longitude. They can look at Jupiter's moons to get a form of tide. The way that they were navigating were much smarter than us. They used basic latitude, right? Just the declination of the North Star at night, and then they could figure out longitude and directions based on all those other methods. So they certainly didn't need it to do anything, nor was it always defined as this, right? This is a very recent modernization, and we'll date it. I think it's the early 1700s when it became this new, quote, modern definition. So if we're looking at it, when we're looking at what we're going to ratio the meter against, a terrestrial meridian is this. It's this right here. It's 1/2 of this, right? It's from the North Pole to the equator. But for our purposes, it's going to be right here from this quarter. This is what we're measuring when we do 69 miles times 90 miles of 90 degrees of separation, 69 miles per degree. 90 degrees of separation here would be 6,214 miles. This is the geodesic arc we're going to be dealing with going forward. But when they start with the arc length, right, when they were saying, oh, it's actually this amount on a sphere, it's funny because there's not a different arc length formula for a sphere or a circle. It's the same. It can be applied equally. So when you're doing it this way, we could easily say that a nautical mile would be equal to 1 minute of this degree right here, spreading out from this circle in all directions. We'd get the same circumference, the same breakdown, the same metric. But that's not what they tell you. right? So we know that the circumference value isn't exclusive. We'll go over that in a little bit, and how seeing in all directions and measuring the sky will give you a equidistant web of stars that will move with you 69 miles per degree. But if we do what we were talking about before, and we use this circle to break down 60 nautical miles, we could easily we could do it. We could divide this into 24 sections, right? We can say each section is 15 degrees, knowing that 60 nautical miles per degree, we do 60 times 15 each section. Each section would be 900 nautical miles, and then we could say, hey, it's 21,600 nautical miles circumference of the circle. So we could plot out the equatorial circumference in nautical miles on this map very similarly. No sphericity required. To get a better visual, we could do it right here, right? Break it down like this, draw these out. Each one of these sections would be nautical miles right on the equator, right? This is what that's referring to. Now, the crux of this argument, right, in this presentation is that things measured in nautical miles will remain consistent no matter what. And here's why, right? This is probably the most important slide that I use here. I like this one a lot. So I'm just going to read it out slowly so we can all concentrate on it. It says, when you perform calculations such as distances using azimuthal transformations, whether the Earth is considered flat or spherical in any model, the distances like those measured in nautical miles remain consistent. This is because formulas that calculate distances based on angles to the stars, like Haversine, we'll go into that next, remain valid regardless of the underlying shape of the assumption of Earth. This means that for navigating and mapping, using a flat or a spherical model doesn't impact the practical outcomes when using properly adjusted coordinate system transformations for distances. So nautical and statute miles retain their values and utility precisely because their definition ties back to the coordinate system, which remains invariant between transformations. So we just went over how the nautical mile is specifically tied to this coordinate system because it is a unit length of one of its metrics that is from a terrestrial meridian, right? North pole to the equator. It is defined as 1/10 millionth. A meter is 1/10 millionth of that, and a nautical mile is 1 minute of traversal on that. So they've equated that distance to the nautical mile and tied it to the coordinate system. If we look at, say, Flat Earth Dave's app, and shout out to Dave, right? I think people who don't understand this particular nuance like to say, why does it use the Haversine on your map? Earth's a globe, dummy. Well, no, it's determining information based on the Graticule, right? The Graticule is a spherical gridded network of long lat based on angles to the stars and your hemispherical flat pane view of everything. And then using the coordinate system of longitude lat, you get Haversine, which literally computes distances based on the coordinate system, right? Latitude and longitude is spherical and curved. It needs an input lat long to even work. If you're going to use it at all, right, you got an ending latitude and a beginning latitude. And of course, anything to use latitude and longitude ties back to the coordinate system itself, as I keep saying. So Haversine and nautical mile specifically are tied to longitude and latitude, or the gridded Graticule, right? Specifically tied to it. If we look at here, this is the Wikipedia definition of the Haversine. And if you were to try and count within this breakdown, how many references to the coordinate system you have, 1, 2, 3, 4, 5, 6, 7, 8 references and inherent to the latitude and longitude of the spherical network within which you're calculating, right? So to say this doesn't apply to a flat Earth, I would say it applies to no Earth. It applies only to the coordinate system within which you calculate it. Any questions on that?
No, so it's just referencing because the spherical system, because the coordinate system itself is spherical, the math used to derive distances from it also has to be in reference to that. So the idea that it's mutually exclusive, it's like it kind of is because it's related to the usefulness of the coordinate system that it's extrapolating distances from. But as we went over how it's mapped out, as a functional coordinate system with negative values, it's not really indicative of the ground still per se. It's just indicative to the coordinate system that you're using it with.
Right. And it would be impossible without it. Your input is latitude and longitude. It does phi 1 and phi 2, starting latitude, ending latitude, right? It'd be impossible to calculate it without longitude and latitude inputs and outputs.
Right. And because the radius, circumference, all that stuff isn't mutually exclusive to a sphere like that aspect of it, which is like the boundary conditions for the equation, still comport with, you know.
Yep. So it comes down to that 69 miles per degree thing in measurement, and then where and when that applies, and then from that they extrapolate sphericity, right? Because don't forget their position as a glober. If you're a glober, your position is that everything in the world obeys the law of perspective, with things shrinking in size proportionate to distance. Tall buildings, mountains, tall people, street lights, lamps, everything in the world except the stars. The stars do it, of course, at the same rate, at the same proportionality to distance, but for a completely different reason called curvature of the Earth, right? They're saying that the perspective-induced 69 miles per degree lateral precession of the stars is actually not due to perspective, even though everything else obeys the same rule at the same rate. That specifically is the curvature of the Earth, and that is the Steelman of the globular position. So again, if you're standing on the flat plane and you're viewing the sky, and you see the dome above you, right? You see the celestial heavens in the shape of a dome. No matter what model you're living on, the way that you would use basic trig to calculate things, right, or to get a distance, say a ground position, is this. You say you've got a line of protractor above you. If 90 degrees is your zenith, and 180 is behind you, and 0 is above your horizon, and let's just say, to make the computations easy, that we see a star at 60 degrees, right, based off the angle from this horizon, and we can guesstimate a right angle triangle over here where this star is sitting over some position on Earth. We'll call that a ground position, right? We'll go into that in a little bit. But if from our position, we wanted to calculate how far it is to this ground position of this star, we can do so using basic trig, right? We can do basic trigonometric relationships. We can do our friend SOHCAHTOA, and we can use the cosine relationship to get our adjacent over hypotenuse with a known angle. So the basic math would be this, right? Observed trigonometry. We know this angle is 60 degrees. We know this forms a right triangle. We know there's a star up here. We have an apparent position. We're going to use that apparent position to calculate this distance between us. We can do so either via unit circle. You can do offset ulterior angles from 90 degrees to get your 30 degrees. You can do the actual math, the adjacent over hypotenuse. You can get cosine of 60 equals 50, or 1/2 rather, and you can get 1/2 of 60 equaling 30. Whichever way you want to do it, the resultant is 30 degrees is down here. So to get a distance based on that, you have to do the relationship of how many degrees per miles, right? 69 statute miles per degree. So again, that's why that part is so important. The resultant of this is a proportionate ratio itself, not an actual physical Earth measurement. So to get a physical Earth measurement, you have to calculate this ratio that you get as a resultant of basic trig with a known figure on the Earth. So that's why this one comes back around. Of course, we have to use this. If you do the same thing for 60 nautical miles, right, you can do the same thing per degree. You'd get an equivalent output, and this would be 2,074 statute miles. So we go into it a little bit further. You could see. Got a question?
No, which is what a fantastic breakdown of that. So what you just broke down is the backbone of how they were checking the all those ellipsoid models, right? When they would use that ratio and set the altitude, because as we were saying, the apparent position, right? But to do this calculation, you need to set an altitude for it. And what did they set that altitude, Shane?
Yeah, 62.14, I think, probably.
62.14. So they share that same relationship to the position of the North Star to the equator and how it deviates 69 miles per degree. If you take that out and linearize it, like just, flatten it out, using the coordinate system for the ratio, it would give you 62.14.
Yep.
And that is what they use for the altitude. Now they say, oh, you can't triangulate the sun on a flat Earth, because like this was like early in my flat Earth, situation, right? When you would hear the argument, well, how high is the sun? Because they would set you up for it, right? And you'd be like, well, 39.59, right? Because that would be the obvious thing, right? But they're like, well, look what happens when I draw lines to it. None of them triangulate.
Yeah, look at my triangulation fail. Flirt.
But the entire, and then it only triangulates at 93 million miles, right? Because you have to take it
Well,
so
it doesn't.
far out.
Yeah, they just push it so far it doesn't matter. It never actually triangulates.
Correct. But they have this story about how when they push it out that far, it all converges to the same point. And it's like, okay, cool, fair enough. Unfalsifiable, but fair enough. But when we get into all practicality, when we get into how we came up with the dimensions for this place to even start to make the assertions that they're claiming, they assume an altitude of 6214 inherently. So if anyone says, well, how high is the sun? How high is the moon? Where's the moon on the flat earth? What altitude? The answer that you could say, for all intents and purposes, you could say that the apparent position used for triangulation for the usefulness of the spherical coordinate system given to us by the British Crown, the latitude and longitude system, you could set everything at the arbitrary altitude of 6218 or 6214, because that is the relationship that you'll get with 69 miles per degree from the North Star to the equator, using units of measurement that are mandated by the Crown as well.
Yep. Nailed it. Dude, so like if they could pretend that you're on a flat plane with an equidistant web of stars always at 6214, or there's an equivalence to a globe where they have what? No, they have the same web of intermittent stars interacting uniformly with the same 69 miles per degree. It's not like you move 69 miles and some of the stars move with you 1 degree and some of them don't, right? No, they move equidistantly, unilaterally together. They only move together, which is why we always argue that they're a static web, right? Or on the firmament, as some people like to put it.
Yeah. Yeah, it would be more apt to say that you see in your own localized firmament.
I think I'd probably say you only see like because like you're not seeing the whole firmament, right, at any given point. So you're seeing your limited portion of the firmament in your local star dome.
Yeah.
So when we get to that 69 miles per degree, we asked it quite a bit, right? Where does it come from? Well, it comes from just the circumference value. Remember at the beginning when we were talking about defining a nautical mile as 1 minute of arc, we were like, okay, how does that? All you're getting here is a 360 divisor, right? So you start with a value, quote, known 24,901 miles divided by 360 gives you your 69 miles per degree metric. So it's not something that's measured on the ground that we for sure know is true, that we've tested. No, we just know because the math of a circle tells us that's what it can be. So of course we go, okay, if 69 miles per degree comes from the circumference, where does the circumference come from? Well, have anyone heard of your scientism starter kit? Good old
a stick in a shadow,
a curved shadow, or whatever, or a sloppy stick. The only measurement of the circumference value of Earth has ever been known has come from the sun. So Eratosthenes is the most famous one, where he took a known distance. Again, say he knew this curved distance was 800 kilometers, and he made assumptions about parallel light rays, knew that there was a difference in observed angle of this parallel sun ray at Syene versus Alexandria, and he did some math, said, okay, 7.2 degrees divided by 360 of a circle times our known distance gives us, we've calculated a circumference 40,000 kilometers. I think I have the math somewhere. Yeah. We covered a circumference of 40,000 kilometers. So using these observed angles, right, and he's assuming that the sun is parallel, therefore the difference between these two can be used to prescribe a circle. This is how they, quote, measured the circumference of Earth. Notice 0 Earth measurements taking place. We have a sun angle, a sun shadow, an observed sun angle change at a different shadow at a pole. We are looking at the sun. We're measuring the sun. We're computing the sun. We're not computing anything to do with the Earth. So what this is giving you is a maximum or limit of the sun visible to you. So you would plot out a circle of 24,901 miles around you, and that circumference would be the limit of the sun, where you would see the sun rays. That would make way more sense to me. This is just a breakdown of the Eratosthenes math again. Yep. Nope. So we got
quick thing on Eratosthenes, right? Because we're big on primary sources around here. What's the primary source situation like with Eratosthenes and the sticks and shadows stories that we've been told?
Oh yeah, as far as I can tell, none. So they're backed up by other fake Greeks who corroborate it, and you know that every fake Greek is corroborated by another fake Greek. Eratosthenes, we know because he wrote a book, and because, you know, Herodotus, who is the father of history, some other fake Greeks mentioned the books put in by Eratosthenes, and they were further backed up by Ptolemy, right? So fake Greeks upon fake Greeks upon fake Greeks. Could I verify any of these people were real? 100% no.
All right, and next question. This was measured in the unit of a stadia, not to be confused with a a Roman mile, right? So the Romans had their own unit of measurement that was just them pacing, right? 1,000 paces.
Yep.
Now a stadia. Do you know about the documentation regarding this, the history of how long a stadia is in terms of a unit of measurement?
I don't think I included it in my Roman metric, but I can find out real quick.
Well, I happen to know. There's no official documentation of what a stadia is throughout history. Modern scholars got together and agreed that it would be 97% of a terrestrial meridian. So when they tell the story that measured in stadias, Eratosthenes closely measured because it would be weird if he one tapped it, right? That'd be too obvious. But he was so close. How did he get that close? What's the independent unit of a state? Oh wait, there is none. Everyone just agreed it would be 99% of a terrestrial meridian.
Oh, so it's the same problem. Then there you go.
Yeah, this has never been fixed. This is just a story that's been told to us and delivered based off of ratios that when you make it of the same thing, oh, no way. He measured the circumference of the Earth within 99%. How'd he do that? His unit of measurement was a fraction of the coordinate system used to make the stadia, dude.
That's amazing.
Yeah.
I looked it up. It says Roman stadia was 185 meters. An Attic stadia was actually 202 yards. Olympic stadia was 210 yards. Egyptian stadia, 157 meters. Delphi stadia. Yeah, so they just made it up, and they were all just, again, units of ratio of each other, which, again, have been tied inherently to the coordinate system. Go figure. Yeah, the argument that he measured the circumference of Earth is really just saying that he based it on an assumption of parallel light rays and a known, already quote known distance. Where he got this distance, of course, geodetic surveying. That's how they know. We'll get into that in just a minute. Another way to interpret what he was looking at, though, right, would be this. If you just say you live on a flat plane, you say the sun comes in at a local light source, you take an observed angle. What you would map out is this circumference right here. Let me go back. What you would map out, what happened here, is this right here. This circumference would be 24,901. If you were in Alexandria and you observed the sun and you did that same math, then this circle would be the same distance. So you could equally apply your results there. So then the question would become, on what basis are you applying your sky measurements to the ground versus how we're applying our sky measurements right to the sky? I mean, one makes logic sense. One is a definite reach and a reification of something you're trying to find. For example, right, if you're in Alexandria over here and you plot a circle around you, right, 24,901, and then try to project that into what it would look like on a flat map, say, it would look a lot like this. To do it more accurately on a non-distorted thing, you could say that if you were to draw a circle around you from Alexandria, it would look like this, right? So here's what correctly mapped out what the sun angle would be. Here's what it would look like orthographically on a globe. Here's what you get: the same circle being measured, same circle being measured, same circle being measured. So just the results. I think we could argue how you would apply just the limits of the sun. A circumference of 224,901 can be used for the observable celestial sphere as well. So when we get back to our latitude dependency, these are concentric equal circles, right? If this is the equator, then 69 miles per degree this way is how we can calculate it, and only this way. Let's see. So it does not apply equally to east-west longitude, right? Only to north-south. So, I mean, there's many reasons for that, but we'll get into a couple. Funnily enough, in reality and on Earth, the only way 69 miles per degree applies, right, is equal from the center outward. So from north-south only, and it happens to match. There we go. Happens to match in reality. So if you were here and you were to actually look at the sky and process 69 miles per degree, you would get an actual relationship with the stars. This is where that relationship can be observed. It's also where the Gleason's map will preserve its distance from the Great Arc. So we'll get into that in just a minute. Let's break down the meter and how they actually use the meter as a ratio of the coordinate system itself. So Again, we went over the Roman mile and how the standardization of what distance the nautical mile would represent fluctuated and varied, anywhere from 41 to 80 miles, right? Statute miles. So when they say that it varied, they weren't kidding. And then they had, the late 18th century, they said, oh, we're going to standardize it and help everyone by creating this system of measurement. 1791, the French Academy of Sciences, they said, oh, we're going to define it as 1/10,000,000th of the distance from the North Pole to the equator along a meridian that passes through Paris. So a couple things with this. A meridian can only exist on a sphere. If there is no terrestrial sphere, as we're saying, then it must be the graticule that they're measuring from the North Pole to the equator, which has a very good known calculated distance, which then they can use to ratio the meter. It couldn't possibly be the Earth because they didn't know this yet, right? They haven't done their geodetic surveying to get what that absolute length would be. They didn't send their boy to the equator here. So then at the meter convention of 1875, they established it that would be, 6,214, and 1/10,000,000th of that would forever be the meter. How that works out, funny enough, right, is that if you look at, let's say, an equidistant projection and you count lines of latitude 1, 2, 3, 4, 5, 6, 7, 8, 9 to the equator, then 90 degrees of latitude times 69 miles per degree, could we count 10 by the 10 out here, then we get 90. 90 times 69 equals 6218 or 6214, depending on which 69 that you use. And of course, when you convert that to meters, you get 10 million meters, right? Rounded to the nearest 10,000. So 1/10,000,000th of that is, lo and behold, 1.0007 meters. So we've calculated the distance from the North Pole to the equator. No one's measured it, right? I did it right from this chair. No one got up. It's calculated from the precession of the sky, not measured on the Earth. So we're ratioing a meter on a terrestrial meridian, a thing that isn't real, but we've confirmed it by calculating 69 degrees of latitude. So it gets a little sketchy going forward. They do this phase where they historically recontextualize what they ratioed it against. Meanwhile, they're never actually changing the definition. Now, keep in mind, 1.0007 meters is still, 100 centimeters, 1.094 yards, 39.4 English inches, and 3.23 feet. No matter what they historically contextualize it against, it is always and forever based on this original metric. This is the math that keeps adding up. Just because you can later say, I can find a ratio of light speed, perhaps that would equal the same amount, it doesn't actually change that it was originally set to this value in this metric. So they go through a couple historical recontextualizations of what the meter meant once they originally assign it to this fictitious length of a meridian arc, which doesn't exist. They then said, actually, we're going to ratio it against the length of a platinum bar and the meter day archives. And then that wasn't good. And let's see, it looks like 100 years later, they're going to ratio it against the distance between two lines on a standard bar of platinum iridium alloy, right, known as the prototype meter. And then that wasn't good. 100 years later, actually, we're going to stick to 1,650,763 wavelengths of orange red light emitted by krypton with 86 atoms in a vacuum. Lo and behold, guys, this still equals the whole time. They just found a ratio of this wavelength to equal the original one, which to make it work, right? And then finally, they were like, 1983, we're going to make it the length of the path of traveled by light in a vacuum at 1/299,792,458 of a second. So they used light speed, right? Imagine, I guess if they were going east to west, this would be a different value. But that's for a different presentation.
No, it absolutely would. And Ruyong Wang points that out. But yeah, they use that uniform calculation for the ratio. And now this gives them the appearance. Now, this is extremely pivotal here, right? Because before now, we've done ratios of the sky, essentially, right? We don't have an actual physical comparison of a unit of measurement in nature that's independent of the celestial bodies. But here, we're defining 1 second as the oscillation rate of a cesium atom, which they break down 1 second into 9,192 millionths of a second, give or take something, right? So now they have a natural unit of measurement to associate with 1 second of time of an interval. And now they're taking a wavelength of light, which is a natural unit of measurement, right? Based off of its frequency and that wavelength relationship. Now they're associating the distance of that wavelength as a fraction of the coordinate system, but they've done it by linking it to 39 inches, which is 1 meter, which is how they're getting it all back to the same situation, where it can be related to the coordinate system. But because of this wavelength and cesium atom oscillation, right, we've now taken natural things from nature and linked them to the coordinate system, and now they have the narrative that this is like independently verified now, right?
Yes, 100%. Can
And-
never,
and-
no longer be questioned. We proved it.
And this is huge, because I just had a conversation recently with someone. You could watch the conversation on my channel at space_audits. It's with Dr. Blitz on TikTok. And this exact thing came up, and he was trying to assert that, they had these independent units of measurement that, were used to measure the ground and confirmed what was asserted from the sky units. And it's like, no, they're all ratios of the same thing, using coefficients to link them together. So, for example, to link the speed of light with the wavelength, they would use 39 inches, which comes out to be 1 meter. So now, using that relationship, they've now associated the same thing, and knowing and understanding that is extremely pivotal to making counter arguments to what Shane's put forward, like through the historical narrative rather, and adding all this up, where none of this is being confirmed. No one's measuring the ground so far, right? We've only
Zero ground measurements so far. I've done it all from my couch over here.
We started with an arbitrary ratio of a unit circle, and turned that into what we needed it to be, to get exact dimensions, using it as fractions of another coordinate system itself.
Crazy. And it's a good summary. And it's very important to realize and not be deterred by this historical recontextualization. So you're telling me that, after this date, when now it's a ratio of light, if I go back and do this math, now it won't work, right? Because now it's no longer related to this. So wait, hold on, 69 times 90. Oh, it still equals 62. Wait, it still works. It's the same. It made no difference, right? It's still always been the same metric, just because they like to put a Band-Aid over it. For me, this right here is just to try and get rid of this as history, right? They know that this looks bad.
That's exactly what it is, because if you could lay out all this, right, it's extremely damning, shows the exact equivalence. But now, like I said, they've linked natural things to the units of measurement, and this is where they have like the security to, make assertions that their original history of how they did it was correct, because now they have independent verification, but they don't actually. That's a ruse.
Yep. If you see here, the final definition is effectively fixed to the speed of light, yada, yada, but it's known the fundamental concept and metric remained unchanged throughout entire history. So now, when they went to go figure out exactly how to confirm that 6214 figure, because you can't just calculate it from the stars, right? They said it was based on the Earth. So how did they do that? Well, they sent a French, or what is the first geodesic mission, called Mission to Peru, and the Spanish-French geodesic mission in 18th century to Ecuador, of course, where they definitely measured the meridian arc. Somehow they didn't tell us how, but they definitely measured it, probably by calculating it based on star positions and then comparing to their known ellipsoid model at the time, which they definitely had in the 18th century. And it says here, this was one of the first geodesic or geodetic missions carried out under modern scientific principles. Just think Graticule, and the first international Spanish expedition. So again, if we were to define what geodetic surveying is and how we know it, or how they would use it, it says that the Earth's dimensions must be known to enable the exact computation of any of their measurements. So that's weird, right? I thought they were going down here to confirm it. They were going to measure it and compare it to what they calculated, and we were going to know once and for all, this is the length of an arc of a terrestrial meridian. However, they used a method where they had to already know the dimensions of the terrestrial meridian in order to measure it. It says basing computations on a previously known value of Earth. What? How am I going to measure it and confirm it by already knowing it? That doesn't seem fruitful. So it says, yes, geodetic surveying requires dimensions to be known because they're applying it to the model. They're necessitating corrections. They're aligning it to astrogeodetics. And historically, this is how they've been doing it. Now they use satellites to do astrogeodetics. But again, if we're going down there to calculate the length of a meridian, how are they measuring it? How would anyone measure the Earth yet? All we've done is a geodetic survey compared to a previously known ellipsoid model based on elevation angles to the stars, and nothing has been confirmed on the Earth. So Again, this was all done to get the to settle the length of the true length of the meter in 1799, so they could, based on the length of half a meridian connecting the North Pole to the equator. So again, this is what they know, and they know that it's this this long, even though they've never actually measured it. Even if you look up what is a meridian arc, it is literally necessitated by a sphere. So again, if Earth is flat, what are they measuring at Ecuador? Is it a great meridian? And we'll get to the azimuthal equidistant direction preserving aspects and how that straightens out great meridians like that in a second. But just know that when you're measuring meridian arcs, they are literally there to try and prove sphericity. They're saying a meridian can't exist, right? It literally defines from a line of longitude from the North Pole to the equator. Unless there's a spherical coordinate system, there ain't no meridians anywhere. And just to put it here, when you're going to measure meridian arcs, they're literally known for trying to they're known for the determination of the figure of the Earth, meridian arcs. So measuring the length of the meridian, how would you do that? Determine the difference in latitude between the points, and then you calculate the curvature. That's how you do it. Calculate that curvature hard. So never been measured, still never been measured, using the coordinate system, never been substantiated, arbitrarily assumed, calculated, ratioed against everything. That's where we're at. If we quickly revisit our boy Eratosthenes, and we had a question about how he knew the distance between Syene and Alexandria, well, turns out by knowing the distance, it was measured by professional surveyors called BMatists. Okay, so he had his own form of geodesic surveying, and they had obviously known by calculating to their held spheroidal models what that distance between those two cities was for sure. So all of that, of course, means that we know we're on a globe for sure. Everything is coming up globe, and it's like, well, no, have you met the Graticule? The Graticule being the spherical network that people get confused with the globe all the time. They say that it's on map projections, right? Well, no. Maps are projected coordinate systems. What coordinate system are they projecting? The geographic coordinates, forever and always. As Alan kindly pointed out earlier, there was a decree royally put forth that only these coordinates shall henceforth be used, and this is all we've ever seen. This is all the world maps ever would be allowed to input-output. And again, it's not a map projection itself. It is a set of spherical coordinates used to reference positions on the Earth. So again, latitude and longitude are not a map projection. They are themselves the backbone to what is projected into maps. So we're going to briefly cover our datums, WGS 84, NAD 1927, NAD 83. These are all spherical geoidal datums, right? So spherical geoidal datum in, spherical geoidal datum out. That's what this is going to show. Garbage in, garbage out. No matter what you're dealing with, it's input in the model. It's going to be output in the model. We're going to touch briefly on the Gleason's map and how it's going to be used to ratio our terrestrial meridian to find distances between places. But just know that all maps are projecting the Graticule, that spherical network of long lat. I think it's important to point out that globers don't actually know that maps are distorted, right? They're distorted because they're projecting the spherical Graticule, also known as the celestial sphere, because it's a one-for-one copy, not because the Earth is a sphere. Because even by its own definition, it's projecting a spherical coordinate system. The goal would be to prove that this is in fact the Earth and not a projected coordinate system, which you will not be able to do because everyone will admit this is a projected Graticule. It's a spherical Graticule of longitude, latitude. So then the goal would become to prove that the Graticule relates to the Earth, right? So that's where geodetic surveying comes in, where they relate those astronomical coordinates to geodetic coordinates, and they try to make it to the Earth. So that's all kind of fluffed and standardized and corrected to hell, meaning that this spherical datum has never been proved to be the Earth. This has always been the Graticule. It is literally a model, conceptually idealized, created from angles to the stars. One of our favorite depictions of said model, though, is in Gleason's map, also known as an azimuthal equidistant projection. Some people would think that this has hence been debunked or discredited, but in actuality, because of its basis as a projected coordinate system, you can no better discredit one projection than you can the other. If a Mercator works, then so does an azimuthal, so does an equal area, so does an equal area cylindrical, so does a Paul-Myers. It doesn't matter. You can't discredit one without discrediting them all, as they're all from the same projected coordinate system. So when we use the Gleason's map, right, it is a true direction or azimuthal projection, meaning it's preserving the direction of specified points on a great circle. Very important to note. And then they say that the great arcs are rectified or shown as straight lines. So that would be, if we were to show what our great arc was before, here, I'll definitely get into this. Where's my GeoGebra model showing what we were measuring at 6214? I think it was right here. So if we look at this, on a Gleason's map, this distance right here that we're looking at, this 6,214, if we put it right here, this from the North Pole to the equator, right, 6,214 miles, this curved distance gets straightened out and represented linearly correctly, meaning that from here to here is the same curved distance, except now it's straight and it still represents the same amount. That is an aspect of a direction preserving map, meaning it's a facet of the tool that we're using to straighten out those great circle arcs. So when they're saying you can't have great circles on flat Earth, it's like, well, have you heard of the azimuthal equidistant projection? Because our boy Alex Gleason certainly has, right? And he put it out there with some instructions on how to use it. Unfortunately, no one read these instructions, and they try to use the given rulers in the ways that they're taught, which unfortunately, you know, pollutes the projection and doesn't use it correctly. Real quick, when you get this map, it comes with these two rotator arms. I think they're called articulator arms or whatever. We're just going to call them rotator arms. They are meant for the different measures of scale that are on the bottom. This right here and this apply to this and to this. Right, and they're used to measure outward from the center, which is, again, very key because that's how we can preserve our great circles, right? This great circle here out is the same because it's flattened out. And again, it comes with these, I'll call them modular arms. And it also comes with instructions on how to use said arms, right? And it says, based on his own words, he said, you know, within the map are circulator lines from the North Pole. You have indicated by the letter G, and you have indicating arm, put it in the center. It goes along a receptacle. It can then rotate outward. So he calls it a longitude and time calculator because you can calculate the longitude from the time. You can determine the time with the map itself. So you can determine what time it is anywhere else using these rotator arms, right? And that's why he calls it a longitude and time calculator. And it's based on the Greenwich meridian, right, running through the line of 0 of longitude. And from there, as long as you use the relationship of 15 degrees per hour, which we all know and should be familiar with, then you get a representation of a relationship. 4 minutes times 1 degree with 15 arcs of longitude. So 15 arc seconds would be 4 minutes. And we can use that relationship to properly understand where the positions are. So he gives an example of how to use it here, dividing it between 4 circles. We can use a different example here. Let's just say, let's see, let's look at the conversions here. So each degree of longitude is 4 minutes of time. Because of that 360-degree relationship we went over earlier, when we're looking at the map, you can divide it into 15 degrees per hour into 24 sections to get the 360 degrees of your circle. And you can know that when you measure the angle of these degrees, then you get the difference. So how that would work is you would line up this arm, say, with New York over here, and this arm with, I don't know, whatever this South American country is over here, and you would physically measure the angle that these two arms create, and you would use that to determine the time. So let's just say, let's see here. If it gets like 12 degrees, you multiply that, and you get the distance between these two. So if you do that, then the local time is ahead of Greenwich, and then the other time is behind it. So they do east-west, and they do positive and negative features for that. What gets confusing for people, I think, is that on the bottom of the Gleason's map is the scale. So people tend to look at the scale and then start trying to apply it all over the map and try to measure things and try to make it work. That doesn't quite work that way, right? It's a time longitude scale. Right, so they're using the bottom one to comport longitude to 1 hour of sun time, and then each degree of longitude to 4 minutes of sun time. And the top one is a 69 miles per degree scale meant to be applied from the center outward. So then would you use the map, right? Actually, let's go over this. Example for an application would be if you to measure a distance of 90 miles, and that would correspond with 1.5 degrees of longitude at the equator. And then those 1.5 degrees would be multiplied to get sun time. And then you use the difference to determine where the time is at that location. So the time gets crucial to determining longitude because it just gets equated to degrees. Now, if we were to see how people want to use this scale, like they get this map, they try to look this and they say, look, this doesn't work. It's broken. Show me a map with a real scale. And it's like, well, if you were to use the tool correctly and understand the coordinate system with which it scales and how it straightens out great circles, meridian arcs, etc., you'd apply it just like this. This scale would line up neatly. You'd measure outward from the center, 69 miles per degree, as we went over before. The other way to do it is, of course, longitude and time calculator. So we can determine a time difference using this, right? If we know New York and Tokyo, we can get the time difference between the two. And then we can use that difference. We can convert the longitude difference to time using the 15 degrees per 1 hour, half hour angle calculation. What it would look like in practice is this. We would place one arm at Greenwich, London, right at 0. We'd place the second arm at New York, and that would create an angle of 74 degrees. We'd measure that between the arms, right? This would be a 74-degree angle. This isn't representing that, but it would be something like this, right? That would be 74 degrees. We get the timing difference. 74 degrees times 4 minutes over 1 degree would give us a difference of 296 minutes, which is roughly 4 hours, or just under 5 hours. So they say, hey, if it's 12, then it's actually 7:04 a.m. in New York. From that, you can use to get an actual difference in distance, and you can use that longitude to calculate at that scale, 69 miles per degree, to get the distance between the two. So when people say the Gleason's map doesn't work, no, it exactly works. It computes distances between the coordinate system, right? A good way to look at it is the distance isn't determined by the visual scale. It's determined by the gridded network of longitude and latitude behind it. Real quick, we can look into this video. I think it has sound, but we don't need sound. This was put forth real quick as a tool on someone misunderstanding the Gleason's map and trying to get us with a gotcha for the sun. And the sun in particular can be tricky unless you can apply it correctly, right? So right off the bat, a Glober put this out and was like, look, first of all, the sun angles don't work. All you guys are at different spots on your flat earth dirt pizza, right? And the sun's over here and nobody can see it in the right spot. First of all, right, if you're drawing straight lines on this azimuth Euclidean projection, that is incorrect. This is not a eastward vector, right? This is east and west are circles. If this is going straight, I don't know what direction he's looking, but it isn't where the sun is. So that's a common misconception. People use straight lines on the Gleasons. That cannot work. When we get into it, we actually we put a observer focused azimuthal grid over each observer, and then we can see that only will that make the sun observed azimuth make sense when you have a limit of spherical view above you, right? When you're trying to use this projection as a tool, be aware of its inherent distortions when trying to show things, right? I myself use it all the time for sure, but I'm very conscious of how it gets distorted and how to use it. So if you're displaying things, right, you can know that Australia isn't this size. Obviously, it's an aspect of this projection straightening out its meridians and distortion inherent from the center escalating outward. So we know that, and we can use this tool anyway by moving it further out here than we would in here to represent the same distance. So we're not saying we're moving further. We're saying that we know the distance scale is skewed. So using it for the sun, though, let's see here. Whoops. I think I lost my whole video.
Yeah, you went all the way back to the first slide.
I thought that bar was for the video. That bar was for the whole press. All good. And we're back. Sort of. Cool. So right about here, we go into mimic each observer's centric position. So we, instead of doing these straight lines orthographically drawing on this map like a retard, we can go and do actual application of tools. We can preserve the direction preserving aspect of this azimuthal equidistant projection. We know that it currently is only preserving directions from the center. It preserves directions from the center point. You could technically make a new azimuthal equidistant projection for each one of these points, but we're just going to move this azimuthal grid and use the observer focus part of it. So again, we're going to focus in on one of our observers using our grid and this map, and we can see, oh, exactly where the sun is where this observer claims to see it. once we utilize the tool correctly. All right, we do the same thing with our other observers. I think this one as well comes right in here. So go to this.
Real quick, this looks kind of confusing because we have like the true position of the sun overhead representing its GP, right? And versus how we see it in our local azimuthal grid. So it almost looks like, there's two suns, or you would see something differently or whatever. But what all anyone ever sees is what's in their azimuthal grid, which corresponds to a ground position. But that is how you perceive it. There wouldn't be like a difference between the two. You know what I'm saying? Because that's what I think is creating a lot of confusion. You're only seeing it in how you would see it with respect to its ground position. There's not like two different perspectives of it. Does that make sense?
Yeah, no, I see what you're saying. So like, it's definitely good to know that there is a ground position of the sun, as that similar to how I said they constructed the celestial sphere with multiple alt-az grids. Literally, people making the same observation within their limit of horizon from wherever they are on Earth. The same thing applies to the sun. You only ever see it in its apparent position, and then this sort of third-party orthographic position is extrapolated to get the ground position. So a bunch of local people make an observation on their local grid, and then they figure that out to get where the ground position of the actual sun would be. But again, that's never measured either. That's only ever calculated, and it's based on solar zenith at the equator.
Nice. That was a fantastic breakdown of the Gleason's map, bro.
Nice. I just want people to still, like, it's a tool, right? It's not broken. It hasn't been debunked in any way. Only people using it incorrectly and not understanding what it's showing, I think, can be debunked. Because again, these are all the same.
Yeah, you touched on it earlier when you said that to debunk one would be to debunk them all, because none of them represent the ground. They all represent positions of the stars. Like, that's the usefulness of it. It's not like they're all representing different things when they're under different projections. The purpose of this coordinate system is that it can be projected onto different projection types and still represent the exact same thing. So if you were to say that like one map doesn't work because of a visual obscurity or something like that, that's a fundamental misunderstanding of the coordinate system itself and its usefulness, right?
100% couldn't agree harder, which brings me right into this, right? When people are comparing flight maps, flight routes, distances, lines of arbitrary length representing what they prescribe and pretend to calculate as different distances. So let's nip that in the bud. When we talk about flight paths, we are talking primarily of arguments of proximity, of things that would be closer when we're talking about emergency landings. We're not talking about distances and visual scaling because it is always projected on the same coordinate system. A good example is this flight over here, which I mapped out and then projected on a couple of different projections. It actually represents 6,000 miles, 5,997 miles, right? This is the distance of the flight. So no matter where you plot it, right? 6,000 miles, also 6,000 miles, still 6,000 miles, definitely 6,000 miles, 6,000 miles, still 6,000 miles, right? No matter how you look at it, it's always going to be that distance. So no matter the visual scaling of the projection in which you're currently looking at it, the distance that it represents in reality tied to the coordinate system is never different. So to have debates and arguments over, one different projection of the same coordinate system and to say how that doesn't make sense, but one does, is asinine to me. Asinine. So that ties up, I think, the Gleason's map and distances. And real quick, we're going to say how we keep referencing the stars and the terrestrial and celestial spheres, right? So we should know that I didn't make that up. That goes back to the Geographia, which is the oldest book in existence talking about cosmography. It was written by Ptolemy, right? That's his book. And in his model of Geographia, the very first preface chapter, the very first figure, is he accepts the two-sphere model, meaning you have to, in order to understand his book or to understand cartography or to know the foundation of maps at all, you must accept the two-sphere model of the cosmos. That is the conception of the heavens as an immense sphere and the earth as the center sphere. So literally, if you don't accept the amalgamation of the terrestrial and the celestial spheres, then you can't read his book or understand anything that he's talking about. So he's assuming that, you know, this is the father of geography, the father of map making. And he himself said, for ancient geographers, it was always considered with first instance defined astronomically. Just wanted to put that quote in there because the terrestrial and the celestial spheres is actually the backbone of the map making. And in that, it inherently links the terrestrial to the celestial and maps this theoretical spherical Earth, which doesn't exist, to the known observed celestial sphere. And that's been the case ever since. And it's never changed, and it's still going on to this day. And that's pretty much it.
That last part you touched on, about the distances looking skewed, determined on, you know, which map you're looking at, even though they're all the same.
Yep.
I was watching a video on intercontinental ballistic missiles, and they were showing, you know, how far they could reach from the central of the United States to all these different places around the plane. And they were using a Mercator map, and like the 5,000 mile mark looked the same distance as the 7,000 mile mark they had on there, you know, but because of the way, and they weren't going like over the pole like you normally would do to hit Russia or something like that. We wouldn't go through Spain, you know, or France to get to Russia. You would go, you know, the quickest way is directly over the pole. But yeah, I mean, the maps, pick a map and you're going to find issues with it. They're not meant to mimic reality. Like you said, it's used as a coordinate system for whatever you're using it for. Doesn't matter which map you're looking at, you're going to get to the same place.
Yep. I mean, I always like to say, because Globers like to harp on it, like, it's because it's projecting the sphere stupid, right? Like this right here. Like, the inherent distortion in each projection is definitely an aspect of the sphere being projected onto a plane, right? A 2D map representing a celestial sphere. In my mind, though, it's representing the celestial sphere akin to what an astrolabe used to do, which is a downward stereographic projection of the sphere onto a flat map. So the argument for maps then would become to prove to me that the sphere being distorted is the actual spherical Earth and not the spherical Graticule coordinate system. And that's where I'm at, because they can't actually separate those two things, I'm finding. No glober can separate the Graticule from the globe Earth.
No, it's built into it. It has to be there.
Yep. This guy gets it.
Yeah, I've been having a lot of conversations about, you know, what the true map and this and that, and I've been trying to tell people we don't know that yet. You know, we have a good idea based on what the sky does and all this and that. But in my opinion, until there is funding put into this, you know, like kings and queens used to do to try to map out the Earth and see how far it went and all that kind of stuff, it's kind of a guessing game right now. It really is. I mean, I love all the thought and all the ingenuity and thinking that goes into it, but I don't claim I know what the real map looks like. Not yet.
Nope, but I'm not afraid of using any of the tools that I find,
No,
right? Any of the
exactly, yeah.
projections, like whatever I think works
Well,
for
yeah,
whatever
they
I'm
work.
trying to show. Like, I
Mhm.
will use them all because I'm not afraid of them. I just think people getting afraid of their tools is where we don't want to be. Like, oh, I don't want to use that. People are going to make fun of me. Well, no, like, people are retarded. It's okay.
Yeah,
Yeah, and they're always going to make fun of you. So
Yeah,
it doesn't really matter.
regardless.
Embrace it. Embrace that you're, you know, have resolve and understanding in your position.
Yep.
But yeah, from what I saw, that was an awesome presentation there, man. I was listening, but I didn't get to see a lot. And I couldn't hear the when the videos were playing.
Oh, no, I didn't share with sound.
Yeah, no worries.
I don't
But
think
yeah,
I had any
enjoyed that.
videos. Nice, thanks, man. Much appreciated. And this one does have good visuals, though. Really excellent visuals that some awesome dude made in Canva or whatever.
Yeah, I'll put another link to the Canva Prezi in the chat for everyone. So if you guys would like to download this presentation and have all the slides for references for future argumentation on your social medias, you can pull them right from the Prez there and just copy paste them into your social media of your choosing.
Yep, each one can be a meme that you can weaponize upon your friends.
Oh, there was one I wanted to wanted you to go over. So the other day when we were talking to Guy McGuyerson on TikTok, and he started saying that if you use 6218
Oh yeah, I meant to show
as
this
the
one.
thing, yeah, could you show that up?
I
Or
think
show
I
that
ended
for us?
up skipping that for some reason. I think we were talking about something else. Yeah, no, let's definitely go into that because, like I said, when you go to TikTok, stuff like this gets weaponized immediately against you, and if you're not familiar and super comfortable, it could become trepidatious. So let's see. Yeah, this is a meme that a Glober tries to weaponize, right? So now this is from a person who definitely does not understand the aspects of the Gleason's map that we just went over them, because if he did, he would have known that this right here is representing a curved geodesic on the coordinate system, but is representing it at the same metric rate. So his whole argument here is that, oh well, if 69 miles per degree and 90 degrees of separation between the North Pole and the equator, then 69 times 90 or is 6214, and then his mistake here is trying to create another circle of this circumference from a sphere, right? It's like, but the circumference of a circle with radius 6210 would be this. No, it's wrong. It's not flat. It's because he's trying to go backwards from the point that it's already straightened out, and he doesn't know that this is actually from the spherical coordinate system in the first place, and that's why it's representing this great linear straightened out arc. But yeah, they were like, oh, someone was trying to lay this out very slowly, but we already know the point is that you're misunderstanding that this is actually a linear geodesic, if you will. So it's a straightened out great meridian arc. And once you know that, then the rest of that doesn't make any sense.
Fantastic. As if anyone has any questions or comments, you are welcome to join the stream, or you can ask in chat, whichever is more comfortable for you. But if you want to come on and ask questions, here's the link. Actually, I don't think that was the link. Nope. Sure wasn't. Sure wasn't. Here we go. Here's the real link for realsies this time.
Yeah, and big shout out to Bolton's again. If you like a good burger and you're in the area, what was that, Charlotte we were near? Mount Holly, North Carolina, near Charlotte. I don't know, it took me back home to when I was young. I grew up in kind of a small town surrounded by cornfields with, like an actual downtown, like one of the old 1880 type downtowns. And it just took me back home. I love those small little towns like that. But yeah, it was cool. We had a nice little meetup there. Nice little group showed up.
Nice.
Nice,
Shout out
making
to
me
the
hungry.
Flat Earth crew and the meetups.
Hell yeah. Someday I'm going to make it to a Flat Earth meetup and meet some real life G's or whatever.
Oh, it changed your life, man. It does.
We might have something going on June 17th, dog, at the Salt Flats.
Ooh.
Never been there. That's one of the things I definitely want to do before I leave this place. I want to see the Salt Flats. I heard it's gorgeous.
I heard it's curved on certain days or whatever.
Well, I will keep you posted on
it. All right. Stop sharing then.
All right. Pizio asked, what is a straightened out Great Meridian arc for the 6214?
It's the same distance, man. So they just took the same distance that is from the North Pole to the equator on a theoretical sphere. And the Gleasons, because it straightens out those Great Meridian arcs, displays the same equivalent distance. 6214.
Yeah.
There's no arc chord relationship there, I think is what he's trying to get at.
He says the 6214 is the surface of the celestial dome from the ground height midpoint across the sky dome.
It's so it's the furthest point. If you were to do a celestial sphere centered over the observer and then sine and cosine your way to apparent height and apparent distances, sine and cosine respectively, when you set the hypotenuse there at 3959 to give you your spherical, limit of vision, then the furthest point that you could possibly see a celestial object using that math and basic trig on the horizon as it rises is 6218. that's also where that comes from.
Gotcha. So hopefully that clears that up, Piezo. We got David here with us from the audience. What's up, David?
Hi. Glad to be on GLOBEBUSTERS.
Welcome, David.
Got a question for you, probably one that you've dealt with before. What do you think of Lindsay Harris' conception? Yeah, his model.
Who's that?
Lindsay Harris.
Tomb of Philosophy, Tomb of Illumination, Flat Earth Philosophy, I think.
Oh,
Yeah,
yeah,
it
you'll have to take that one.
used to be Flat Earth Philosophy, and now Tomb of Illumination. Yeah.
Well, I mean, speaking for myself, I dig Lindsay. I think he's got the right ideas. He calls all the things that I think of different names, so it's hard for me to conceptualize what he's referring to because everything in his verbiage is different than in mine. And then he has a tendency to speak from instead of say an analogous or in a simile or in a biblical way, he'll go from extreme to biblical to antithetical to reality, and then he'll bop back to biblical, and then I'll get some like a metaphysical metaphor for feminine and masculine, and I'm like, listen, man, you gotta stay in one form of communication or I can't follow. But that's just me personally.
Yeah, he scatters it a bit. Yeah.
The method of communication it changes so frequently and so drastically, it's hard to keep up.
Yeah, but he was on GLOBEBUSTERS a long time ago when it was the philosophy channel, and I noticed that Whitsitt said he's got nothing against the concept.
Well, yeah, I think he's describing a reality that I subscribe to, right? Like the way that he describes the world, I think, is how like the sun is always and forever apparent in man's arc of horizon. 100% can subscribe to that belief, right? But when he tries to explain it, I kind of get lost in it. I think I had him on my show a couple times. I talked to him, and I think we agree on most of the conceptions of the dynamics of what it is. But like I said, when he calls something different, his own, and makes up words for all his own stuff, it's hard to communicate. At the end of our talk, I think I was like, "Oh, we believe in the same thing, but we describe it entirely differently."
Yeah, different vocabulary. Yeah.
Yeah, definitely, and different accent too. Different talk. Yeah, you've got to get used to it all. But I've been following that for so long, and it does make sense to me, and so it's nice to have other people who understand that too.
Yeah, I'm a big black hole sun guy, to be honest, when you get into the actual dynamics of how things supposedly work, and it supports an apparent moon and sun and all sorts of different conical intersections that will result in moon phases and say magnetic polarization of light to prescribe as a dynamic mechanism for the things that we see. But that's crazy and wild and out there. I think he believes in mostly that too, though, with a twist.
Yeah, it's all his design is all about magnetics. Yes. That come from the black hole.
Yeah, I think magnetics play a huge role in what's going on, especially in the sky. There's just too many similarities of what we can do with magnetic fields as far as visualizing them down here on the ground, and then that applies when we place it up in the sky too. Like those same arcs and shapes and all the spirographing that can happen, that all is taking place in the sky. So for it not to be magnetic would be, now I'm not saying that 100% it is, because the creators, I don't know what he's doing with the sky. It's fun, to ponder and think about, but I'm not going to drive myself crazy over it like I almost did. It's not healthy, for one. It really isn't. I think one of the lessons of this place is that our knowledge is limited. You know, we don't get to know everything. Period. That's just
Yeah.
how it is. It's one of the
You got,
lessons.
you got to take into account the spiritual aspect too.
Mm-hmm.
Yeah. Which is something Lindsay does in his own way. So yeah, there's a lot of aspects to understanding the Earth. Yeah.
Yeah, it's
And
an amazing place. I couldn't believe I was bored at one time.
yeah. And I've been watching Jaron as well, and I find it kind of sad that he's gone the way he has, and I get the feeling you need to think out of the box. Yes, and he's sort of boxed himself in.
Yeah, I know Jaron pretty well, and if it doesn't make sense to him, you know, he has a hard time. It was the same thing with the whole vector thing. That,
Yeah.
you know, that spat that went on in GLOBEBUSTERS for a while. The whole idea that there needs to be a vector in order for, you know, density and buoyancy even to take place. And once he got that locked in, you know, it was okay. But this is different. I think this is more spiritual, like you were saying. Like, I think it's more than just to try to trick us or this or that. It's almost like the creator saying, look what I can do.
Well, I don't think there is a trick. Yeah, it's just as it is.
Mm-hmm.
I think God has a sense of humor, to be honest.
I would.
Well, it does say that in the Bible that you know, God is laughing on his throne when he looks down at the nations. You know, because they're all confused.
Someone's.
Go ahead,
Sorry. I was going to bring it to the magnetics again because someone had mentioned the path of the planet. So that's what I'm showing now. I think Witsit made this one, but it's an amalgamation of all like the geocentric view of the path of the planet's perception, the perihelion shift, like how things orbit would appear only makes sense from a geocentric standpoint, right? It's one of the more solid points I think that we have. But then do they follow the magnetic line of the torus field of Earth, right? That would be my first thinking on what would define the pathways of these celestial objects, right? And why do they always keep the same static method? Why do they always look the same? Like this, right? Those are the patterns, right?
It's beautiful.
Well, that is amazing.
And how could anyone look at that and say, look, that's just by happenstance, by chance?
Right. The same people that think a tornado can rock through a junkyard and accidentally assemble a Porsche, I guess.
Yeah. Yeah. All American-made cars, by the way. And a Porsche comes out at the end.
Yeah, so I mean, someone was saying that the pathways, that's one of the things that really got me, right? When in the beginning, like looking at planets and geocentrism versus heliocentrism. And then you get this for heliocentrism. They're like, oh, not only do we have it all figured out, but look at all the wonderful wobble in the indices, and we know everyone's at a tilt. We know our tilt, Venus's tilt, the solar system works. Doesn't work with multiple 3 energy bodies because we never solved the 3-body problem, but we totally figured this out. Trust us, it totally works with 7 or more moving gravitational bodies. Like we know that the whole universe is at a tilt and it's actually chasing a black hole around the galaxy and it's actually making these motions at all times. And it's like, trust us, bro. We totally figured it out.
Can you send me that video you're showing right now? I need that.
Of course. Yeah. So I mean, you can go to one side that pretends to have all the answers and does have answers, but they're all based on nothing and a coordinate system with ratios of themselves. Well, there's a side with answers that actually make sense, that are logically coherent, cohesive, that work well together, that work with other theories like magnetic and, cohesion with the magnetic flux field and how those actually work spread over in the flower of life pattern over the earth. And then one pattern just, one side just makes shit up and just says everything's crazy, wacky. Trust us, bro.
First, there was nothing. Then came everything out of nothing.
No one and nothing caused this. Don't worry about it.
No one. You
And when you
contribute.
die, you
no
return to nothing. Right?
Yep.
Yeah.
Yep. And the
That's
cycle's complete.
Yeah, you return to your creator. That's heaven, right?
Well, that's the Bible as well, isn't it? In the beginning was a void.
The earth was void of form. There was waters, though. The waters of the deep.
Well, I just love the way Lindsay explains that. Yeah.
Well, if you have no electric potential difference or pressure difference or temperature difference change, there's no energy at all in the system, that's the ether to me. When that's you have a blank canvas, there is no anything, right? The earth is void of form. You have your canvas, and then the creator started making frequencies of vibrations and turned that ether into stuff, matter. And we have what we have here. But we don't get to see the ether because we're part of the painting. You don't get to see the canvas from the painting. We only see what's on top,
Well
not
said.
underneath. That's how I see it.
Yeah. Yeah. Incredible. Yeah.
And we can't create that. We can't make zero potential. It's not something we can do in a lab even. There is no zero potential. We can't do that. Go back to nothing. Yeah, I think that's what, Satan, the opposition of creation, that's all that means, to oppose the creator. That's what it's trying. That's what Mother Nature, what they call Mother Nature. That's what Mother Nature is trying to do. Equalize everything. High pressure to low pressure. That's all it's doing. Everywhere we see potential differences, trying to equal out to zero.
Balance.
But it never will.
Yeah.
It never will. There's just too much going on. Too much energy being added into the system at all times. So it won't come to zero. If it does, that's when it's back to the ether. In my opinion. So yeah, every day I wake up and I see that sun coming around, I say, all right, I get another day. Thank you.
Thank you for our daily rotation of the sky.
Sending those energies down to keep this place doing what it's doing. It's a beautiful system. We were talking about that at the meetup. What more can you ask for? Water falls from the sky. The one thing we need to survive falls right out of the sky.
Yep. We're going to be wrapping up soon. If anyone has any further questions from the chat, or David, if you have anything else.
No, I was very surprised that to get the link actually, and surprised to be here. But I really did want to ask the question about Lindsay, because I think he's doing a really good job. Yeah, he's sort of, it's his concept is a work in progress, and he's certainly winning.
Yeah, nice.
Hey guys, how you guys doing?
Welcome, sir. How are you today?
Hello, man.
Good, good. My name is Lance. I'm from Pseudosciences University channel. I got a question, a ponderance, if I will. You guys are a lot smarter than me, so I'll just run by you and you tell me if this is possible or not. Right? So we know that gravity. Can you explain gravity to me in a nutshell?
Gravitas, we know things go down and have weight, right? So little g would be the rate at which things fall over the earth. That's pretty much it.
Okay, so it's quintessentially an interaction between Earth and mass, correct?
Well, in the current scientific mainstream consensus, yeah, I think so, right?
Okay, so if we look at what mass is, we break mass down. It's matter, and we break it all the way down to the molecules, particles, atoms, particles, or whatever. Now we're in a subatomic particle area. So we know that the mass is the sum of the atoms compacted, making it be what it is, physically, visibly, correct?
Mm-hmm.
Right. So
Yeah,
what is
yeah.
happening
At
inside
the
of the atom?
well, it's subatomic, they don't say it's gravity anymore. That's when the strong force comes in. The
Right. Well,
strong
so let's just
nuclear force, and those have more to do with electricity and magnetism. They believe they don't know yet.
exactly.
Yeah.
No, that's the truth. That's the truth, right?
Mhm.
So quintessentially, now if we consider Earth magnetic field, and once you understand, once things have a mass, and certain atoms dictate frequencies that they exist in the physical realm, you can nobody can really deny that gravity quintessentially is an electromagnetic force, correct? Because on the subatomic level, that's what's going on. And the accumulation of all the atoms building these, because watch, atoms are comprised of protons, electrons, and neutrons. The electrons be agitated and revolve around the nucleus and generates an electromagnetic field. If you have a mass that is 50 pounds, the atoms are contributing to the mass. That electromagnetic field, of course, is neutralized once it becomes a mass. You get into frequency. But in quintessentially, it seems to me that this is an electromagnetic force. I'm just running it by you. I'm not saying this is what's been in my head, and I just want to get you guys feedback on that notion.
I don't think you'll find disagreement here. I think most of us prescribe it as electromagnetic force with its both inherent manipulation and its effects, right? You got the gravimeter in a thunderstorm report. You got definitely we can change the direction of the downward vector with electrostatics, overwhelming the so-called gravitational force, changing the vector down. So I think we all agree on that. And I think Whitson says it all the time that, like, show me the thing with show me matter without electrons. So show me that matter isn't held by the universal electric charge. And when you can't, then the statement is everything is magnetic, right? So.
Well,
There he is.
electromagnetic is under the same frequency. Now consider this: Earth, the sun, right? The sun, we consider it plasma, right? And when you look at a plasma, in a sense, in all plasmas, rather, it just depends on what is being heated to these degrees that cause it to form a plasma, correct? So you gotta have a hydrogen that's going to form a type of plasma. You're going to have so let's look at the sun, and let's consider the polar regions. When you look at subconduction, right, and you see how things are locked in place, right, and you consider the analemma of the sun, you can see that it's creating a spiral motion. I forgot what it's called. It started with an H. That motion you just showed it. I forgot the motion, but it's a spiral motion that's going around the Earth.
Helix?
The latitude lines is a representation of the trajectory of the sun's spiral to the southern circle, right? But as it spirals out to the southern circle, it goes up. So it increases in altitude as it goes south, right? So this is why you're in Antarctica and you're able to see the sun from Antarctica. That's simple. No matter where you at. Now, and you got to also look at Antarctica is in the flat Earth paradigm. Antarctica is a ring, but it just don't start at ice wall. It starts at lower elevation and it gradually goes upward when you go towards the wall, the ice wall, which is mountains, not a wall with bricks. It's mountains and mountainous areas, terrain that's connected to the said ice wall, right? Which I figured out. Well, let me just continue. My point is this: the sun's electromagnetic field that is similar to what's happening on a microscopic level, right? The sun's electromagnetic field actually contributes to daylight, if you will. Like we have noble gases above us. They become ionized when the sun crosses into their doing this spiral motion over the seasons. This is our daylight, right? If the sun is kept in its place and the moon is kept in its place doing this, it has to do with something of subconduction, right? Because we see the locking in place on a minor scale. And that's what is the temperatures in space? And what is the temperatures when they're in their southern and in their northern solstices, right? So they're teetering in between, it seems to me, magnetically. Do you guys disagree with that?
No, it seems like they're forced to stay within some kind of torus field. You know, they can only go so far north, and then they can only go back so far out to the south. You know, it's
Now,
like they're in that little donut.
Now I figure how, right? Because when I was studying the sun, I seen that the sun is actually a hollow sphere. It's basically nothing on the inside and everything is happening on the outside. Now, why do I say this? Because plasma attracts matter. Plasma itself is attracted to a magnetic field, an electromagnetic field. That's the center, wherever that invisible thing is that's attracting plasma itself. But plasma itself attracts matter, right? So I looked at the moon. I looked at the recent study that I think it was back in 2007 or 8, and the moon, it no longer reflects the sun's light. It actually illuminates an albedo that is of X-ray and gamma radiation, right? And that's the low level glow that we get from the moon. It does come from the sun, but it's not. It's the NASA data says that the moon emits light with no earth shine or sun glow or sun light, right? In the NASA thing. So I'm saying, what if the moon and sun is made of a crystal type substance that's also magnetic? And because if the dome is shaped, the scriptures say the dome is sapphire. Sapphire is a perfect insulation towards electromagnetic properties. It's blue. It also is see-through to light. It's transparent to light, and it also refracts the light. So the scripture says that God's throne is made. I bounce back and forth because I use all of the data, science, ancient, ideas, and what did they think? Because we got to go from the beginning to now to have a better understanding of everything. So I see that the heavens is sapphire, and sapphire is and it doesn't conduct electricity well. It's transparent to light. And where would they get this knowledge to use sapphire as the dome? And quite possibly, the moon and sun is also the orb of sapphire, because what happens is they magnetically are repelled away. Sapphire is repelled away from magnetism. So it's just a salad of ideas. I never get on to get to you guys. I'm home. I'm able to see you, so I threw a lot. But just sharing some stuff.
No worries, man. Yeah, a lot of your electromagnetic ideas, make sense, and I really like them. And I think this place, the electromagnetic component is highly underutilized here. And there's definitely different ways to conceptualize gravity and like the cause of it per se, right? Because we actually don't really know. That's like the battle of contention between everything, right? Because they have their asserted mass attracting mass inheritance. There's a electrostatic gradient component. There's a downward measured velocity change in light, which would correspond to like the light traveling faster due to some mechanism. So there's like different things to consider pressure wise in this system that we're in that would facilitate 9.8 meters per second squared, relative to the latitude or whatever, with slight variations. But in regards to what the physicality of the objects are and how all that works, that part is what I would consider like, pure cosmology, where you're just kind of like trying to conceptualize a model of how you think it would work based off of like physical material properties and how it would respond with how you're conceptualizing the cause of the motion and stuff. And you know, there's nothing wrong with that. I just have no idea how we would ever verify or anything of it. And then further, in terms of like the physicality of the objects in the sky, I think it's important to remember that we all see apparent objects in the sky. They're not like a physical, we don't see like a physical relationship, you know, it's all personalized to us. So it could be anything, you know. But yeah, I really like what you're putting down, man, and where your head's at.
Very interesting. Humans can create sapphires in 4 different ways, and they are identical to those found in nature. A hydrothermal process, the flux method where it's just elements are dissolved in a solution, and time that's what the flux is. Flame fusion, and then another method, I'd butcher the name, CZOCHRALSKI process, where radio waves are used to create sapphires. So very cool. Yeah.
And you'll see the optical properties, and they're also, like I said, I actually looked it up as I was having a hunch, and I'm like, why would these ancients pick of all of the stones sapphire to be the firmament?
Yeah, Cami has talked about this before, about if she had to pick one, I'm pretty sure that's what she would have picked.
Yeah. Well, I just wanted to share that with you guys. I am the Pyramid Earth guy. I one day kick it with you guys, you know, and let you see the model, the actual Earth. The Earth is 3 parts. The land itself is shaped like a mountain, but seeing as though it has 4 corners, literally South America, Australia, Africa, and the Zealandia continent that's under the Pacific, is 4 corners literally there, and they all merge in the north. They go up. It's a 7,797 foot diameter or something like that, going towards the north. So we know that that shape is clearly, even in the latitude lines, which are conal, the area space matches the latitude. The less space, the smaller the circle. As you go south, they widen, which is letting you know it's more space. That's a pyramid, right? But just sharing it with you.
Awesome, thank you. I'll put a link to your YouTube channel in the chat for everyone. They could check out the model. I haven't heard of the pyramid shaped thing. I'll check it out.
All right, guys, have a good one. Thank you.
Thanks, man.
Thanks, dude. I hope it wasn't that dodecahedron in the sky built from the concave people when they misunderstand meteorological impacts from an ecliptic radar system.
Nope, that's a different triangle.
Good.
But yeah, that's awesome, dude. So yeah, we're about to wrap up here. What do you guys got going on this week? Starting with Zach.
Hanging out over at Iron Rail Media, Rumble, here on the YouTubes, Friday or Monday, Wednesday, and Friday mornings. Then we do a show Friday night too at 6. And this week, I believe, sorry we didn't do GLOBEBUSTERS Tech last Thursday. We have a topic for this week. I think we're going to do those, what is it called? The invisibility shield and how that works. Have you seen those where they take
I've heard of it.
Refractive, it'll be like a big, like 3x4 foot sheet, and you can go and duck down behind it, and it looks just like it did before you went and ducked down behind it.
Oh wow.
Yeah, it's pretty neat.
That's crazy.
Yeah, they've gotten it down to where like you and I could make them now. It's that simple.
Oh wow.
Yeah. So we're going to be going over that this Thursday. It was something cool that, you know, we haven't talked about in a while. I know Bob talked about it the first time I saw it.
Nice.
Years ago. So yeah, coming back around again. But yeah, that's what I got going on this week.
Awesome, dude. Iru, what do you got coming up, brother? All right, nothing. He bounced. Respect. Shane, what do you got coming up?
I was going to ask you, man. Are you presenting on Tuesday, or are we phoning something in on Tuesday?
So to start us off, Monday. Oh wait, here, hold on. Iru's back here. Let's let Iru get in. Welcome back,
Hey,
Iru.
Yeah, hello, hello.
Iru, start talking if you're a Jesuit.
Yes, Jesuit. No, I Jesuit. No, I didn't know that we start with video again. So I'm gonna put my camera handy on my.
Hey,
Yeah, hand camera. I was looking at the presentation. Amazing. I think I need to finish the last 15 minutes because I have a phone conversation. But amazing presentation, guys. Both of you are, for me at least, it's like it made me feel that we get back to the old times of GLOBEBUSTER when there is a lot of information and based on data and analysis and things like that. In fact, I feel a little off of the information that you handle. All that type of number equations, formulas, things like that is like a master class. So thank you for present this and take the this space or this new GLOBEBUSTER series, because for me, when you make this type of presentations, I think the people must be appreciated because it's like a fresh air and coming back again to the basis of what it was GLOBEBUSTER, in my opinion. I don't know if you understand what they're trying to say, but thank you.
Understood.
The bottom line is
is,
thank you.
That is the desired effect. Thank you, sir.
Sentiment well received. Thank you, man. Much obliged.
And what's coming up for me? Well, I am in 3 days. I return to Argentina, so I was. It's a little mess in my schedule because I need to keep going doing things in my Spanish channel, but at the same time, I need to wrap around everything here to get back to Argentina for the next 4 months, and my head is all over the place.
Nice. Well, looking forward to seeing what you got coming up when you get time. All right. So, what Ether Cause has coming up soon? Monday, we're going to be doing a game night. It'll be a Flat Earth trivia night or code names night. I can't remember. With Flat Earth related questions. Nope, it's definitely going to be Flat Earth trivia. Okay. And then Tuesday, Dom and I from the Ether Cause Czech variant will be debating McToon and Peter Markey or Markley or something like that on modern day debates on the shape of the Earth.
Oh, wait.
It's
a different
Hurt
Peter,
my
though?
soul right there.
Yeah, it's not great, but gotta take what you can get or whatever, as they say. So we'll be doing that on the
I feel
28th.
like I just see Alan bleeding out on the battlefield. It's like, get him help.
Well, you're not going to leave him there, right? You're going to be part of the Shadow Council during that debate, I presume.
Send the medics. Here we get the Jesuits on the job. We need medics.
Yeah, man, you need to take a look. I make it. I make by just for get it fun. I like to, time to time check Guy Consolmagno conference, and he's still alive. He's still doing his presentation, and as a Jesuit, he's dropped some Easter eggs in the history of astronomics and things like that. So you never need to get rid of all the Jesuits out there. You need to leave one or two to,
Yeah.
for fun.
To make sure they come back or whatever.
Jesuits
Yeah.
are stay busy, man. They are.
Got a lot of work to do.
Yeah,
A lot of generational plans in motion.
Yes,
you take an
completely
oath.
agree.
You take an oath to get disemboweled. You gotta get to it.
Yep. So yeah, that'll be at 8 p.m. That debate. There'll be a watch party on Ether Cause. So come and join the Discord, hang out for that. And then Wednesday and Thursday will be some sort of TikTok activities that Shane and I will be partaking in. And then Friday, of course, if Flat Earth Fridays has not returned, we'll be hosting a Ether Cause community space. So stay tuned for that.
We'll be ambushing confident Globers on TikTok. That's what we're going to be doing. It's going to be fun.
Yes. Yep. Awesome. And you got anything coming up? What's it?
Yeah. So basically, what I thought I was going to be able to do last week, I think this week.
Nice. So what
No,
was last
yeah.
week's plans?
No, I've stepped away for lots of reasons. I did a private stream with my members only stream. I explained a lot of it. I was thinking about a lot of stuff, trying to decide where to go from here. Lots of crazy stuff going on, people losing their mind, whatever. Stepping back, just kind of. So I'm gonna come back this week and like kind of hit the ground running. I think I'm filming for the Make America Healthy Again documentary. We're going really deep in the fluoride thing. Um, so I'm shooting for that documentary this week. We're going to speak at a city council meeting about fluoride this or the 5th, and then on 18th of February. So not this week, but we're in Bartow. We're speaking at the city council meeting about fluoride because basically what's happening in Florida is every county is doing hearings on the fluoride in the water supply, and they're just getting knocked down one by one. Like basically every county is removing the fluoride. Which I guess we need to break the news to them, which is that it's not refined and it has other metals in it, and there's all kinds of other stuff except for fluoride in our water that's bad. But anyway, the Surgeon General is going to be speaking there. My boy Justin Harvey's been really going in doing this, and so he'll be there. I'll be speaking there. So I plan on speaking at a few of these city council meetings. So that's one of the many things I kind of have planned to hopefully kind of bubble up the channel, and then be like, oh, by the way, guys, the Earth's not what you thought it was. So that's kind of the plan. Yeah, and then that's about it. I'll do some streams. I'm gonna do my Trump stream, basically tying in all my predictions from like 5 years ago, and be like, okay, who's crazy now? So now that
Yeah,
we clearly
that's a
see,
good idea, dude. There are a lot of people right now waking up to a lot of not flat Earth, but fluoride and the red dye, all this stuff that's coming out. Hey, all this stuff we've been eating is bad. GMOs, this and that. It's all going to start coming out. And when you know something about it, like Austin does, go out there and say something. Or at least, if you don't want to do that, send an email or whatnot to your local congressperson saying, yes, I agree with this, yada, 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 yada. They need to hear it, that a lot of people know about this and we're not going to put up with it anymore.
Florida's setting an example, just county by county.
That's
they're
awesome,
pulling
dude.
it out. So yeah, I guess to wrap up, I'm coming back streaming this week, hit the ground running. I'll be in a bunch of X spaces, but a bunch of different topics. I may occasionally start holding X spaces, do the city council meetings. I'll bring back middle ground. I might change the day each week that it happens. I'll probably try to talk to you guys, coordinate with what you guys typically do. So we'll bring middle ground back, that series this week. So yeah, long story short, we're gonna start making content again and got lots of stuff in the works. And hopefully the Candace Owens thing is gonna happen here pretty soon. I'll give everyone the date once it gets finalized. And yeah, that's about it.
Nice. Now I heard you were going to do an exclusive stream on kick.com/witsitgetsit where you were going to be doing a live breakdown of all the Matrix movies in sequence.
Oh, thanks for reminding me.
Is that true? Is that true? You're going to do that? Like a marathon back to back to back all in one shot?
Oh.
Just with live commentary or what?
Oh.
What did you have planned for that?
Back to back. Oh.
For 9
Alan
to
signing
10
me up
hours?
live, tactically proposing the idea live. No, that's a long time. I was wondering, why did you say kick? But now I know.
Yes.
Now I know. Yeah, I do. I am going to do a Matrix decoded series. It's all inverted, and Neo's the Antichrist. It's Gnostic, occultic, Trinitarianism. It's pretty deep. It's pretty wild. It's about rebellious entities. Some call the Watchers, whatever. And it's wild. And when you watch the Matrix and you see that that's what it is, you just can't deny it. It's really crazy. So yeah, I'll break that down. I cannot commit to back to back to back.
All right, we'll do it in a series. We'll do it in a series.
Yeah, I'm open to it, but no promises.
Awesome. All right, well, that concludes the show.
Cool. Anybody else got anything they want to throw in?
Love y'all. Always
See you.
Yeah, thanks guys for having me on.
Love you guys. Catch up with you next week. Hopefully you guys like the new vibe. We're getting back to things. And what is it? Be kind to each other. Don't lie to each other. Open your mind, because there's truth inside. All right. Peace out. Much love.
Bye bye.
Peace.
Nobody that I know of in my field uses the so-called scientific